So in this video we are going to discuss about system analysis and system design, which are the part of system development life cycle. Okay, so what is system exactly? So system is nothing but a set of detailed methods, procedures and routines which are created to carry out a specific activity and which is going to performing a duty or solving a particular problem. It's nothing but a system. It means whatever the procedures, processes, methods, things that you are performing in order to solve a problem or in order to finish a task or duty, it's nothing but a system. Okay, so generally the systems will helpful to get things done in an orderly manner or in a structured manner, and generally system is nothing but the systematic way of doing the things. So another simple definition of system is which is designed to accept the input and processing that input and giving the output in return. Okay, it's nothing but a system. So next thing, what are the characteristics of a system? So it requires some basic components and it is very interactive and it contains some basic structure, and one activity is dependent upon the another activity. Is nothing but interdependence and integration. You can combine all the activities and in a system, and every system has some goals or objectives and behavior. So it is generally systematic in nature, and life cycle. It is nothing but it will follow some series of steps. Based on that series of steps only it will perform the task. So these are all the general characteristics of the system. Basic components, interaction and basic structure, integration, interdependence, goals, objectives, behavior and life cycle. So now come to the point, that is what is system analysis. It's nothing but studying the business processes in detail is nothing but system analysis. It means what's exactly going in the system, how it is running, how it is working, how it is performing. So in order to all know that, you have to study the entire business process. That study of business process here is nothing but system analysis. So in system analysis also we follow some series of activities or tasks or steps. So first you have to collect the data that is required. Once the data is collected, you have to understand the information flow that is carried out in the organization, and you have to find out the bottlenecks or hurdles that are there in the system, or what are the errors that are there with the present system. So once the bottlenecks are identified, next you have to find out the solutions in order to overcome that bottlenecks. So when you follow all these, it is possible to achieve the objectives or goal of the organization. So this is the various things that are done in case of a system analysis. And here, so if you want to perform the system analysis, some expert should be required, right? So who is that expert? The system analyst is the person who is involved in the system analysis part. Okay. So here the system analyst will perform some series of tasks to go for system analysis. So what are they? First, research. Research is nothing but collecting the entire information related to the performance of the system. It represents collecting the information about the present system, and they can also follow some various methods and various sources in order to collect the information. And next one, analysis. Analysis is nothing but complete study of the present system, and they will also identify the problems that are there with the present system. Once the problems are identified, next they will go for design. So in order to fix the problems in the present system, they will go for designing of a new system. Designing of a new system is nothing but solution providing. And production. So based on the design phase, they will go for coding. So coding is nothing but creating the new system from the design. So based on this, whatever the design that is developed, based on that they will go for a designing of a new system. So once the new system is designed, they will go for creating the new system, and they will go for testing. Testing in the sense whether the proposed system is giving absolute results or not, they will check in the testing part. And after that, so if no errors are there, the proposed system is working properly and it is not throwing any errors and it is not giving any failures, then finally how the system is developed and how the system is designed and how the coding is developed, all the things are included in a documentation format. So once the documentation is done, finally they will go for implementation. Implementation is nothing but replacing the present system with the new system. After that, evaluation. Evaluation is nothing but whether the new system is meeting the expectations of the people or not. They will check at the evaluation phase. So these are all the series of tasks that should be performed by the system analyst. So first one is research, analysis, design, production, testing, documentation, implementation and evaluation. Okay, next. So that's about the system analysis. Let's come to the system design. So system design is the next phase to analysis. So in design phase, so here the developer or designer is responsible to transform the requirements into a complete detailed set of specifications. So whatever the requirements that are listed, based on that requirements, they will go for developing a set of specifications. So let's see this. So see this mic and this speaker. So what are the specifications of this? It should, first one is color, length, width, diameter and its appearance. All these are the specifications, and based on the requirements of the organization, that requirements are converted into our specifications in the design phase only. It means, so this should be in the black color, it should be of this much length only, and this holding part should be like this only, its appearance should be like this only, and this model should be like this only, and charging point should be kept at the top of the product. So like this, all these comes under the specification part. So that specifications are based on requirements. So the conversion of requirements into a specification part is nothing but system design. And this system design is concerned with 5 main areas. First one is user interface. It means, so it is a graphical interface which is designed for both inputs and outputs, and the databases where the information is kept, and the network, so how the information is moving from one to another, and the hardware components that you are using, and the security measures that the organization is taking. All these are concerned with the system designing only. And next one, in case of system design, so it has mainly 2 phases. First one is logical design and the second one is physical design. Okay, in case of logical design, so in logical design you have only data and process components. But in case of physical design, so it mainly talks about how that components should be implemented in the system. Okay, so let's come to the logical design in detail. So you can see here the logical design represents the abstract of the entire system, and abstract is nothing but how the data is flowing, what are the inputs and what are the outputs of the system. Like that it will prepare an abstract. So that is a part of logical design, and it's nothing but it is a graphical representation of a system. It's nothing but like a flow chart or a diagram like that, and it also shows how the system is processing and how the data is flowing and what is out of the process and what is in the process. Like that all the things will be clear in the system design, that too in the logical phase or logical design. And so it also describes what task the system is doing without having to specify how. It means what exactly the system is doing and where, who is performing and where it is exactly performing. So all these things are done in case of a logical design. So apart from that, it also covers all these aspects. It is nothing but current, how the current manual system is there, and its review, and preparing of output specifications according to that, and preparing the input specifications, and preparation of additions, securities and control specifications, and specifying the implementation plans, and what are the benefits, what's the cost that is incurring, what are the target dates and what are the expected dates, and any constraints are there related to the system. All these are covered in case of a logical design. Okay. Next one, physical design. So physical design is completely the part of the developers. So why I am taking that, it is completely part of the developer, in the sense whatever the processes and requirements, that components that you had listed in the logical design, so the implementation part is taken care by the physical design only. So physical design is completely carried out by a developer, system developer. So for example, if you take computer hardwares or softwares, DBMS files, manual files, screens, reports, forms, it's not possible to carry out by an ordinary person. So that's why the developer will take care about all these things. Okay, and here also the physical design exactly shows the relationship between the internal and external entities and how the data is flowing, and it also relates the actual input to the output process of the system. Okay, and here the programmer is allowed to write necessary modifications according to the software packages, how it has to accept the input and how it has to process the data and how it has to show the results, and necessary calculations, files, databases, the entire things will be managed by the programmer, and here the programmer will write the necessary programs and go for modifications according to the changes. So this is how the physical design will work. Okay, in case of physical design, we follow 4 steps. So in order to design a physical system, first you have to specify the input media or output media, and after that you have to create a database, design a database, and you also have to go for backup procedure. Once the backup procedure is done, you have to represent the physical information flow. So this is the first part. After the designing of the physical system, we'll go for system implementation. So system implementation, for this you have to prepare a conversion schedule and targeted date, and once this is done, you have to prepare the procedure of training and timetable according to that procedure. So after that, you will go for testing and implementation. So in testing and implementation, you will go for designing of new softwares and hardwares. So once all these done, based on all the implementation, we will update the benefits, cost and conversion date and system constraints, if any are there, financial problems are there, hardware components are throwing any errors or not working properly. In such cases, they are all considered as system constraints. All these are updated at the last stage. So these are the series of steps that are involved in the physical design. First one, designing the physical system, plan system implementation, devise a test and implementation plan and specify new hardware or software, and update the benefits, cost, conversion date and system constraints. So this is how the system design will work. And finally, let's come to the system designing tools. So if you want to go for system design, whether it may be logical or physical design, so what are the necessary tools that you require? First one is data flow diagram. So if you want to represent the data flow diagram, it means if you want to represent it in a pictorial manner, so you require some tools. It means it like you can see here. So this is one is circle, this one is square, this one is rectangle, and this one is diagonal. Okay. So like this, these are the various symbols generally used in the flow chart to represent the flow of information. Like this, here also in case of system design also, we use some particular tools in order to represent the activities that are going in the system design. in a pictorial format. Okay. And second one, decision table and decision trees. So generally decision table is nothing but it represents the conditions and the respective actions to be taken to address that conditions in a structured format. So ER model, so entity relationship model, in the sense it clearly represents the relationship between the entities and the database in a pictorial format. So first one is data flow diagram, decision table and ER model, that is nothing but entity relationship model. Next one, data dictionary. So data dictionary is nothing but, so it is the centralized collection of information and it is nothing but it acts as a repository of the data. Whatever the data is there, that contains the dictionary. So related to that system, whether it may be new system or old system or proposed one, anything, all the terminology related to that system is maintained in the data dictionary. So if you want to design the software, so if you want to know some terminology, you can check this dictionary. And next one is data elements. So data elements is nothing but description of data, like what's the name of the field, description, and where exactly that file is stored. In order to all know that information, we will go for data elements and data store. So generally these are the file names and tables that holds the data of the system. So whatever the information is there related to the system, that information is maintained in some table or some file or some master file. So holding that is nothing but data store. And structured English. So if you want to go for coding or representing the system and documentation of a system, you have to use simple and understandable English for everyone. So that is the structured English. Means everything related to the new system should be represented in a simple English. So this is how the system analysis and system design will go in SDLC, system development life cycle. Okay. So in the next class, we will discuss about system implementation and system evaluation. Thank you.